want to introduce the idea of functional notation, and I want to first bring this about through an example, and then we'll kind of talk about what that means. All right, so I want to write the following in functional notation, and we don't know what that means yet, and I want to evaluate these for x equals 0 and x equals 2. Okay, so the first thing I'm going to do here for a is I want to solve for y. I want to get y equals something. Okay, so I have 6x squared minus x plus 3y equals 2y plus x. So I'm going to get all my y's on one side, so I have 3y minus 2y gives me 1y. And I'm going to get all my x's on the other side, so that's going to be a negative 6x squared plus x, and I believe that's everything. So then y equals negative 6x squared plus 2x. Okay, now I'm going to now replace the y with this, f of x. That is read as f of x. And that means that I have a function now who has this x is my input and this is my output. Okay, so the x is called an independent variable. That means I am free to choose what x is. Okay, the y is called a dependent variable, and so it's dependent upon what x is. You pick the x, that determines the y, and so because of that I don't really need to write y at all. I have f of x, which means that f of x will be the output determined by the function when I plug in f of x. Now a good way to think about this is whatever you plug in for x, it's like an open box. Whatever you put in to that spot has to go into all the boxes. So for example, if I said I want to know what f of blue is, then that's going to be negative 6 times blue squared plus 2 times blue. Okay, whatever I plug in the first box has to go in all the boxes. So for example here, where it asks for f of 0, that means anytime I see an x in my function, which is right here, anytime I see an x, I need to write 0. So I have 6 times 0 squared plus 2 times 0. You add that up, you get 0. So f of 0 is 0. And f of 2 would be negative 6 times 2 squared plus 2 times 2. Alright, so that's going to be negative 6 times 4. So that's negative 24. Plus 4, I end up with negative 20. So those are my two function values. Now as a way to visualize this with set notation, or the set diagram, I have my function here, f, and when I plug in 0, that maps over to 0. And 0 is also f of 0. And when I plug in 2, that mapped over to negative 20. And negative 20 is f of 2. When I applied the function of f to 2, the output became negative 20. Okay, I hope that makes sense. Alright, now let's look at b part and let's do a similar thing. So I want to solve this thing for y, and so that gives me 9y plus 2 equals 6 times 3x minus 1 over 2. So the 3x minus the 6 and the 2 cancel, so you end up with 3. So I have 9y equals 9x minus 3 minus 2, right? I distributed the 3 and I brought the 2 over. So then y ends up being x minus 5/9. There's my y, and I'm going to replace y now with f of x. And you don't actually have to use f. Why don't we change that to g of x? So g of x, the function g, is defined by x minus 5/9. So whatever my input is, I have to take that input and subtract 5/9 from it. So for example, if I want to know g of 0, that's going to be 0 minus 5/9, which gives me negative 5/9. Okay, so remember again, whatever you plug into that box has to go into all the boxes. So now if I want to know g of 2, I take the value of 2 and I subtract 5/9. Okay, so I have to think for a little bit. 2 in terms of ninths is the same as 18/9 minus 5/9. That gives me 13/9. And so there are my two function values. The negative 5/9 is what the output is when your input is 0. 13/9 is what the output is when your input is 2. Okay, now I want to further expand upon this idea of functional notation by looking at these examples. I want to determine f of x minus 1 and f of x squared. Now this may look a little confusing, but what I'm saying here is that my input into these functions are f of x, or x minus 1 and x squared. So remember, it may be useful to write your function as f of something equals negative something squared minus 7. And whatever you plug in to your box here has to go into all of the boxes. If you plugged in coyote, so f of coyote would be negative coyote squared minus 7. Alright, so now if I want to know then f of x minus 1, that means I need to replace all the x's with x minus 1. So that's going to give me an x minus 1 squared minus 7. Okay, so then if you want to clean that up a little bit, that's going to be negative x squared. What's x minus 1 quantity squared? So that's x squared minus 2x plus 1 minus 7. So then f of x minus 1 is actually negative x squared plus 2x, and then you have a minus 1 minus 7, that's a minus 8. Okay, so there's f of x minus 1. That's what that looks like. Now if I wanted to say what's f of x squared, this time I need to replace that box with the value x squared. So I have negative x squared quantity squared minus 7. And so that cleans up to be negative x to the 4th plus 7. Okay, and there's my function value of x squared, f of x squared. Alright, now so again what this means is whatever you plug into here as my input has to go into all of the x's. You replace the x with your input. So for the next one, for example, I want to first of all replace my x with x minus 1. I'm going to have the square root of 1 minus that input minus 3. And again, I'm plugging in x minus 1 into these. Okay, so that's going to look like f of x minus 1 is the square root of 1 minus x minus 1 in parentheses. So that's going to be the square root of, well, let's see, if you distribute that negative, you end up with a 2 minus x minus 3. That's what your f of x minus 1 looks like. Now if I want to do the same thing for x squared, this time I'm replacing my input with x squared. So then my f of x squared then just ends up being the square root of 1 minus x squared minus 3. Okay, and I think this example is trying to bait us into thinking that that's the same as 1 minus x. But that is not true in the least. Okay, that's not true in the least. So this actually is the correct answer. F of x squared is the square root of 1 minus x squared minus 3. Okay, this is a basic introduction to functional notation and how to change your inputs in functional notation. It's very useful. This is very practical in the world of mathematics, and it helps open up a lot of doors. If you have any questions on this, I'd be glad to help, and thank you for watching.